This character is dodging obstacles in a fast-paced game. If you guess your way through geometry, you end up moving like a lost NPC and taking massive losses on your tests. You can level up your navigation by understanding what trigonometry is actually doing. We start with a right triangle. That square corner flashing right here means it has exactly a 90-degree angle. This shape is the foundation for this entire system of math. Everything relies on this single corner. Look at the arrow pointing away from that 90-degree corner. It points directly to the longest side of the triangle, which is glowing right here. This side is called the hypotenuse. Its name never changes. Now, notice the target icon appearing in the bottom right corner. This is your POV, or your point of view. You pick one of the remaining corners to be your anchor, which defines the names of the other two sides. Following that dashed line across the room from your POV, we hit the far side. This is called the opposite side. It is the one stationed entirely across the shape from your current perspective. Then we have the side glowing solidly right next to your POV. This is the adjacent side. It is the side that directly touches your anchor corner. Watch what happens when the POV target shifts to the top corner. The opposite and adjacent sides instantly swap identities. Because the perspective moved, the side across the room changed and the side right next to you changed. Identifying your perspective is the first step to knowing the players in your triangle. If you lock down your POV, you can label the sides correctly before you even write down a number. As this 30-degree right triangle scales up from tiny to massive, the fraction counter stays locked. If an angle stays exactly the same, the ratio between its sides never changes, no matter how big the triangle gets. To remember which sides pair up for these ratios, you use the shorthand SO, CA, TOA. SO, or sine, is the opposite side divided by the hypotenuse, showing height. CA, or cosine, is adjacent divided by hypotenuse, showing width. TOA, or tangent, is opposite divided by adjacent. The hypotenuse goes dark. Tangent purely compares the two straight legs. SO, CA, TOA provides the map that links the angle you know to the specific side lengths you are missing. Imagine you are on target at the very top, and you need to figure out exactly how high up they are without climbing. This wireframe forms a right triangle. Ground distance is the adjacent side. Vertical height is the opposite side. The diagonal hypotenuse fades out. It's unneeded. Knowing adjacent and needing opposite, you use tangent. Multiply the distance by the angle's tangent to reveal the height. Tangent allows you to measure unreachable vertical heights solely from your perspective on the ground. You get the data without doing the physical work. But what if the problem gives you the lengths of the sides and hides your POV angle instead? You have the measurements, but the angle is missing. For this, you run the math in the opposite direction. If you have the ratio of two sides, you can work backward to find the angle. Check out this visual loop. While normal trigonometry takes an angle to produce a ratio, these inverse functions, called arcsine, arccos, and arctan, run the machine backward. You drop the ratio in, and it spits the exact angle right back out. Game developers use these ratios constantly. The code uses sine and cosine to split a diagonal dash into horizontal and vertical coordinates. Phone navigation apps use arctan to calculate the direction of your path. They convert your straight line distances into a heading, keeping you on the right track. Trigonometry is a tool for navigating the physical world. Label your triangle, identify your POV, use your ratio, and collect the W.